Good morning, everyone. Do you know how tiny 1 nanometer is? Well, to say that a sheet of newspaper is 100,000 nanometers thick, and there are 25,400,000 nanometers in an inch. This would give you an idea as to how tiny this nanometer scale is. But isn't it amazing that modern science has been able to wiggle down its way to the very bottom of the scale and has managed to create magic even at this microscopic level? And that's how we land up with another miracle of science, nanotechnology. A very good morning to respected Principal Sir, Vice Principal Sir, our guest speaker for the day, revered faculty members, and all our dear participants. I, Anushka Man, am delighted to welcome you all on behalf of the Department of Chemistry, Ramjas College, University of Delhi, to an enlightening national webinar on nanotechnology, the promise and the challenge. Before we begin, I would like to announce that owing to the constraints on the Google Meet platform pertaining to the number of students, we are also going live on YouTube, the link for which can be accessed from the poster and the chat box. Someone stated that people are like stained glass windows. They sparkle and shine when the sun is out, but when the darkness sets in, their true beauty is revealed only if there is a light within. Therefore, let us begin today's program by kindling the flame of wisdom within us through the auspicious lamp lighting ceremony. I request respected Principal Sir, Vice Principal Sir, our guest speaker, and my mentors to kindly allow me to begin the ceremony.
Yes, Anushka.
Thank you, sir. When darkness comes our way, we shall seek to illuminate rather than cursing the gloom. When ignorance clouds our eyes, we shall seek to drive it away with the lamp of knowledge. On this note, let us give this webinar a fresh start. It is said that integrity, insight, and inclusiveness are the three essential qualities of leadership. Our respected Principal Sir, Professor Manoj Kumar Khanna, has truly exemplified all these qualities through his able leadership and guidance, which has given us wings to fly and explore new heights. Due to some reasons, Sir is unable to join us today, but he continues to send us his blessings for all of us. I also extend my warm welcome to the revered Vice Principal Sir and IQAC Coordinator, Professor Hemant Kumar Rajor, who has always been a source of motivation for all of us through his never-ending quest for bigger and better for the college. Sir, I welcome you to today's event and I request you to kindly share some words of wisdom.
Thank you, Anushka. Good morning, our esteemed speaker, Dr. Smriti Sharma Bhatia, teacher in charge, Dr. Shruchi, convener and co-conveners of the webinar, Dr. Siza Jedi and Dr. Sheetal Buddhiraja, and other organizing members, faculty members, students, and dear participants. On behalf of Internal Quality Assurance Cell, Ramjas College, I welcome you all to the webinar on nanotechnology, the promise and challenge, organized by Department of Chemistry, Ramjas College under the aegis of IQAC. Our esteemed speaker, Dr. Smriti Sharma Bhatia, Associate Professor, Department of Chemistry, Miranda House, University of Delhi, will be presenting about nanotechnology in a very simple way so that our students can understand in a simple and smooth way. Certainly, this talk would be very beneficial for all of us and would know about the very relevant topic at present, that is nanotechnology. Once again, on behalf of Ramjas College, University of Delhi, I welcome and thank you for your active participation in the same. We look forward to your august presence in future events also. Stay safe and stay healthy. And I apologize that our principal sir could not join in today's webinar as he had already his prior engagements at the same time, but his blessings are with us. Thank you very much. It's up to you, Anushka Man.
Thank you, sir, for enlightening us. We eagerly anticipate to grow and flourish under your able support. I feel privileged to extend my welcome to our revered teacher in charge, Department of Chemistry, Dr. Suruchi ma'am, who has always pushed us to think out of the box and has motivated us to become a better version of ourselves. Ma'am, I welcome you to today's event and I request you to kindly share some positive words with all of us.
Thank you, Anushka. Let's start with some positive words, as you said. I asked for strength, then the world gave me difficulty to become strong. I asked for wisdom, then the world gave me problems to solve. I asked for courage, and the world gave me danger to overcome. I asked for love, and the world gave me troubled people to help. I asked for favors, and the world gave me opportunities. I got nothing, but I received what I needed. It is a modified version of quote which teaches how we convert challenges into opportunities. With these lines, I welcome all of you to the today's webinar. A very good morning, all present here. I would like to express my heartfelt gratitude to the organizing team who sincerely committed to this event to make it a success. Today, we have a very prolific, multi-talented, and generous speaker, Dr. Smriti Sharma Bhatia, and I am proud to say that she is my lab mate and an amiable friend. I thank you, Smriti, from the bottom of my heart for taking time from your busy schedule to be the guest speaker at our webinar. I am sure that the participants will be benefited and enriched with knowledge after today's talk. Thank you so much. Over to you, Anushka.
Thank you so much, ma'am, for your kind words. Before we begin the lecture, I would like to introduce the Department of Chemistry, Ramjas College. The Department of Chemistry is one of the oldest and largest departments of Ramjas College, comprising more than 30 highly qualified, dynamic, and vibrant faculty members. It offers admissions to BSc Honors and BSc program courses and also admits students for doing masters in chemistry. It provides one of the most modern and essential facilities for the students, including well-equipped laboratories. Students from this department are doing exceptionally well in various career fields. The Department of Chemistry focuses on the holistic development of the students. Not just academics, but the extracurricular activities are also given equal importance. Despite the problems posed by the COVID-19-led pandemic, the department has still put exemplary efforts in organizing various webinars and lectures to ensure all-round development of the students. Following the same pattern, the Department of Chemistry has organized yet another illuminating webinar today. Starting as a tiny budding idea in a talk entitled "There's Plenty of Room at the Bottom" by physicist Richard Feynman in 1959, the concept of nanotechnology has bloomed gracefully over the years. To conduct science, engineering, and technology at the nanoscale is truly an exemplary fiat. As promising as this sounds, this technology brings with it a certain set of challenges too. We have Dr. Smriti Sharma Bhatia, Associate Professor, Miranda House College, University of Delhi, here with us today to discuss the same and make us delve deeper into the world of nanotechnology, its promises and the challenges. Before we begin today's talk, I would request all the participants to kindly keep their mics muted during the course of the webinar. Any questions pertaining to the talk can be posted in the chat box, which would be taken up at the end of the talk. I would now like to request Dr. Shiza Zaidi ma'am, faculty member, Department of Chemistry, Ramjas College, to kindly introduce the eminent speaker for the day.
Thank you, Anushka. I hope I'm audible.
Yes, ma'am, you are.
Okay. Respected Principal Sir, Vice Principal Sir, our honorable guest, dear colleagues and students, a very good morning to you all. Beyond simplistic observation lies a world of minuscule dimensions. To venture into such domain, several young scientists have admired the field of nanotechnology not in vain. With this, I welcome you all to this national webinar on nanotechnology. To enlighten us on the techniques, the insight information on how to fabricate and characterize at the nanoscale, we are extremely honored and privileged today by the presence of our honorable guest, Dr. Smriti Sharma Bhatia from Miranda House, University of Delhi. Dr. Smriti Sharma Bhatia is an associate professor of chemistry at Miranda House, University of Delhi. Her academic and research interests include computational chemistry, nanoparticle toxicity in plants, and educational technology. Along with the PhD in computational chemistry, she also has postgraduate diploma in educational technology from IGNOU and a diploma in applied nanotechnology from Biolim Varsity and certificate course in French language from University of Delhi. She has had an active interest in research along with her teaching career. She has undertaken 6 major research projects with funding from DBT, UGC, and University of Delhi. She has been a summer faculty research fellow at IIT Delhi and has guided many research students at DSKC Miranda House. She has close to 50 publications and has presented her work at various national and international conferences. She is a member of various illustrious research bodies like the Indian Science Congress Association, Indian Women Scientists Association, Materials Research Society of India, Indian Society of Analytical Scientists, and many more. She regularly contributes as a resource person and consultant to NCERT, EPG Pathshala in Flibnet, and has given numerous popular science talks. She is active in community service and is working for the cause of organ and body donation in India for the past 20 years. Dr. Smriti, today we are privileged to have you amongst us. On behalf of Department of Chemistry, Ramjas College, and all present here, I welcome you. Please enlighten us with your talk. Over to you, Smriti.
Thank you so much, Dr. Shiza, for that lovely introduction. And it is always a delight to come to Ramjas College. Some real, fine brains here, and we discuss about science and everything. And I'm very thankful to the principal of this college, vice principal, sir, and of course, my seniors, Dr. Suruchi and Dr. Shiza Zaidi, both very positive and very warm people, and to the to whole of the organizing committee and the student coordinator, Miss Anushka. So I think your students are really very, very intelligent and very brilliant. The way she conducted the webinar so far, it was amazing. So I'll start my talk as Anushka has said. Nanotechnology is a game changer. So I'll just present my screen and we will start the lecture. Okay, thank you. Share. Can you see my slides?
Yes, ma'am, we can.
Okay, perfect. So, as you saw, the title of my talk is Nanotechnology, the Promise and the Challenge. So, you see, basically, I would be dividing my talk into roughly three sections. First section would be just understanding the basics about nanotechnology. The second section would be applications of nanotechnology and why there is so much hype surrounding it. And the third section would be the challenges and how students can, for teachers and students, what are some of the open source resources that they can use to gain knowledge about this technology. So let us start. As Anushka rightly pointed out, what is nano? Nanoscale means 1 billionth of something, right? 10 raised to the power minus 9 meters. So if you have a 1 meter scale and you divide that scale into, you draw 1 billion lines equally spaced, 1 billion lines on that scale, then you will get the distance between two lines will be 1 nanometer. And the scale that is important is 1 to 100 nanometer. So relevant dimensions that are important for nanotechnological fabrication characterization is 1 to 100 nanometer. So you see, why it is gaining so much currency is because there are so many, biological molecules that are in the nano range. So if you see, just have a look at this. Gold atom is water molecule is 10 raised to the power minus 1 nanometer. Viruses are in the range of 100 nanometers. DNA is 10 nanometer, 5 to 10 nanometer. Bacterias, red blood cells, all these are in the range of nanoscale. Nothing brings home than this picture, makes it very clear what we are talking about. This is a human hair, this log, wooden log like thing. This is a human hair. You compare it with nanofibers. So it is 80,000 nanometers long. So just imagine if you have 1 nanometer, so 80,000 times that would be your hair, one single piece of hair. And if you compare it with the RBC, red blood cell of our body, just have a look. This is the RBC, and this is a human hair. So you can imagine, the kind of scale we are talking about. So what is nanotechnology? See, if you're talking about nanotechnology, then you have to understand that if I say the human hair is 80,000 nanometer, that is not nanotechnology. That is not the range of nanotechnology. 1 to 100 nanometer range is mostly, all over the world. That is conventionally taken as a range in which if you have a system structure that has a novel property or a function that you are characterizing that function, that particular structure at this scale, if it has dimensions in 1 to 100 nanometer range, that will be known as that will be known as some anything related to nanotechnology. So basically you should be having the ability to control and manipulate on the atomic scale. As like any science or any technology, nanoscience is the study of fundamental principles of nanostructures between bulk and atomic properties. And nanotechnology is the application of those principles. So first you understand the principles, that would be nanoscience. For example, in third year you have a paper also, so you're reading the text, that is and internalizing the fundamentals. But when you apply those, that would be the technology, and I would be talking about the application part, the technological part. So, the question is, why so much buzz now? What is like nanotechnology? Your teachers would tell you that it has always been there. There was a chapter in NCRT of colloidal science. So, colloidal science was there 50 years back, also 100 years back, also. That is sort of all the theoretical principles of nanotechnology come from colloidal science only. So, why so much buzz now? This is because now we are able to characterize at the atomic level. We can characterize very, very small molecules at the atomic level. Then we can manipulate the atoms or the molecules. We have got the tools. We can pick up atoms and draw things. For example, IBM, a scientist working at IBM, with xenon atoms, he drew IBM atom by atom. So there are tools available for single atom or molecular manipulation. So these tools have been developed. So that has also given an impetus to nanotechnology. Then, very important point, I am a computational chemist, and I can tell you this with 100% certainty that there has been the simultaneous growth in the computational science has also led to growth in nanoscience. Why? Because, for example, my PhD was on nanostructures, nanotubes. So, what happened was I manipulated carbon nanotubes on in a software, and I compared it with like its reactions with the experimental values. So there has been tremendous. Just a second, please excuse me for one second. Yeah, sorry. Am I audible? Hello, am I audible? Yeah.
Yes,
So
you are, Smriti.
okay.
Go
So
ahead.
there has been, tremendous growth in computational science. What I could do in my school days on a personal computer, and that personal computer was also very big. What I could do on a personal computer, you all can do that on your phone, on your smartphone. So there has been a tremendous growth in the hardware, and commensurate to that, there has been a tremendous growth in the software. So you can study the big molecules like nanotubes and all. You will get confused that how come the nanotube is a big molecule when you're talking about 10 raised to the power minus 9. I will come to that. So you can study these large systems on computational using computational software. So that has also led to its growth a lot. And then this is very important to understand, this is the time of interdisciplinarity. There is no physicist, no biologist now. I can't say that I'm a chemist, so I won't venture into biology or physics. This is highly this is a time of multidisciplinarity and highly flexible careers and all for the students, I'm saying. So your skills will matter, and even if you're a physicist and you know how to engineer DNA, so you will be like that will be a very good asset for the job market. You will be an asset for the job market. So nanotechnology is also like that. So it is not confined to one particular branch of science. I can't say it is only chemistry. A physicist can't say it is only physics. So it is a fusion of various disciplines. There is a lot of interdisciplinarity in nanoscience and nanotechnology. So that time has now come. So that is why these four reasons, in my opinion, are causing so much buzz about nanotechnology. Then what is yeah, we have to understand some theoretical background. I have to give you. After that, I'll discuss the applications. So we have to understand that what is special about the nanoscale. At nanoscale, three things happen. First, the this your teachers also must have told you that quantum mechanical laws will be followed, not the classical mechanics laws, because it is a microscopic it is a nanoscopic system rather. So quantum mechanics would be ruling. First is that. Second, sizes are very small, so gravitational forces, they become negligible. That is very important to understand. And now electromagnetic forces dominate. And third, this all of you must have read in catalysis that if you have a block of charcoal and if you have powdered charcoal, so since surface to volume ratio is high in powdered charcoal, so obviously you will have powdered charcoal would be a better catalyst. So same thing happens at nanoscale also. Surface to volume ratio increases. So three things: quantum mechanical laws govern the nanotechnology, gravitational forces become negligible, electromagnetic forces dominate, and greater surface to volume ratio. So these three things are special about the nanoscale. So what happens is, because of these changes in the environment, what happens is everything changes. They have unique properties. They don't have properties like macroscopic objects. They have better catalytic efficiency. Their electrical properties are better. Increased magnetic coercivity and mechanical strength increases. Optical properties, optical properties, we are really using nanotechnology in optical in changing the optical properties of bulbs and all. I'll just come to that. Then spherical properties, biological properties, all these things change. For example, to give you one example, this is a very oft quoted example of change in the optical properties. What is the color of gold? The thing comes to our mind, yellow. But in case you go at nanoscale, at 1000 nanometer, the color of gold nanoparticles would be golden. 1000 nanometer is like a compared to the nanoscale, it is a big number. 700 nanometer, it will turn red. 600 nanometer, it will turn orange. So color change is happening. With nano change, the color is also changing of the gold nanoparticles. They are not no longer yellow. The color would change to red, orange, blue. So same for silver nanoparticles. So this is how the optical properties are changing, and similarly the examples can be given of all the properties that change. Now my talk is just a primer on nanotechnology. You can delve deep into it and study of all the properties, how those properties change and all. I don't know if nanotechnology is being offered in your college. So all that is there in the theory. So how do we work in nanotechnology? So you see, there are two approaches in nanotechnology. One is top down. This is how a sculptor would sculpt a statue from marble, say. So it will etch down all the material that is not required, and then the statue would emerge. This is known as top down approach, right? So it is being used to make chips and processors. But now the bottom up approach is gaining currency. This is like building materials atom by atoms from legos, so you assemble atom, then atom, and then you make the then it you bring it to the nanoscale, and you make the structures. So this is also known as third generation of nanotechnology. uh, Bottom up approach is supposedly more see, traditionally we have been following top down approach mostly, so bringing the thing to the nanoscale. But from atoms to bring it up to the nanoscale, that is the bottom up approach. Now it is gaining currency. So why is it so? We will come to that in due course, in the course of this lecture. Please remember these points. We will come back to these. So nanomaterials, if you have to classify, they can be organic, inorganic, or hybrid. So organic nanomaterials are fullerenes. You must have heard about them, nanotubes, and cellulose, biocellulose, the electrospun nanofibers. Inorganic are metals like silver, gold nanoparticles, copper nanoparticles, and metal oxides. They are also very good nanoparticles. Like they have very good, nice properties. So they are really used. For example, TiO2 is used in cosmetics a lot, in your sunscreen and everything. Then you have quantum dots. Quantum dots are being used for optical properties. They are metalloid nanoparticles, cadmium selenide, zinc sulfide. So these are being used in LED and all, and they're also, quantum dots are also, they're being used in solar cells. So they are trying to develop paints that have these properties, that they can harness the solar energy. So if you have to install solar power, plant in your college or in any building, lots and lots of big structures have to be installed. But what nanotechnology is helping the scientists to develop, so quantum dots, paints make quantum dots are incorporated, and then you just apply the paint, and the whole building will act like a solar harnesser. So that is like, it seems to be science fiction, that but very serious science is going around to develop this. And if we can harness, if because solar energy, if it can be harnessed in this way, that will be really great, because then your car can also be painted, and then you can harness that solar energy to power the car. So it is like 20-30 years, it may take, I don't know how much time it will take, but maybe 10-15 years. But still, all around the globe, labs are working on these concepts. Okay, and theoretically, what do you call it, they have the, like, principally they have developed it, but there are bottlenecks when you scale it up for commercial production. But this is happening. So, and the third classification is hybrid nanomaterials. So hybrid nanomaterial is that can be a mixture of organic and inorganic. So it will be, if there are two organics, nanoparticles are being mixed, that is organic hybrid nanoparticle material, organic inorganic, and similarly inorganic inorganic. So you will find these examples in various research papers that come across, so do read about it. Then this is very important, and sometimes I've seen people getting very confused about this. So I've included this in my talk, dimensionality, nanomaterial classification based on dimensionality. So see, you have to understand, when I say zero dimension nano material, that would mean zero. None of its dimension is in the macro scale. Zero dimension would mean all of its dimensions would be in the nanoscale. Students mostly get confused that zero dimension hai, to no dimension is in the nanoscale. No, it's the opposite. Zero dimension would mean zero dimensions are in the macro scale. So all the dimensions are in the nanoscale, X, Y, and Z. So these are quantum dots. I just spoke about quantum dots, your fullerenes, okay? And rings, atomic clusters, all these come under zero dimension nano materials. Then you have nanotubes. So one dimension would mean that one dimension is there in the macro scale, rest are in nanoscale. So nanotube would be can be very long. So I just, if you recall, I said that I did my PhD on nanotubes, and they are very large systems. And I told you that you can ask me, how come nanotubes are large systems when nanotubes are supposedly in the nanoscale? So you have to realize that the nanotube can be very long, that length can be in the macro scale, that makes it very large, but rest two dimensions are in the nanoscale. So if I have to perform the calculation on a computer, the more the length, the difficult the calculation becomes. Here the computational power comes into play. So now it is very much possible to calculate on very big nanotubes also. So that ways the nanotube becomes a larger system because of its dimension. Okay, so so metal nanorods and nano wires are also there, which are like one dimension may, they are very long, but otherwise the two dimensions are in the nanoscale. Then we have two dimensions, two-dimensional nanomaterials. So now by this time you must have understood that two dimension would mean two dimensions are in the macro scale. So length and breadth, the films. So one dimension, only the, say the height or whatever would be in the nanoscale, and rest would be in the macro scale. So these will be very, very thin uh, films, plates. For example, if you have if you have 1 spoon of paint, nano paint, okay, and with 1 spoon you can paint an entire football field with 1 nanometer of length. मतलब कि आप coating, you can coat the football field, a whole big football field, with just 1 spoon of nano paint. If you have to coat 1 nanometer length, like if that coating has to be 1 nanometer length, so you can coat the entire football field. So that coating would be a two-dimensional thing, because only in one dimension, that is the height or whatever you want to call it, that will be that will be nanometer, in the nanometer range. Next is three-dimensional nanomaterials. Now, this is very interesting. All the dimensions, none of the dimensions are in the nanoscale. So, what do you think? Like, how will these arise? If none of the dimension is in the nanoscale, how do we say that these are nanomaterials? Any answers? I hope I am audible. Yes,
Yes, ma'am,
students?
you're completely audible.
So any answers about this? That in three-dimensional nanomaterials, none of the uh, materials, none of the dimensions are in the nanoscale. All of them are in the macro scale, and we can actually touch those materials. So how come this is a nanomaterial? Any question? Any answers? Okay, you can try and answer. Try answering this. Think about it. See, the thing is, these are three-dimensional nanomaterials are the assembly of nanomaterials, nanoparticles or nanotubes or nanorods. These are assemblies. So at the like structural level, they are nanomaterials. They're composed of nanomaterials, but when they are composed of nanomaterials, after the it's like a brick, it is in the nano range, but when the whole of the wall would be in the macro scale. So these are assemblies. That is why they are known as nanostructures. Okay, so these are three-dimensional nanostructures. So now we've got four generations of nanostructures. We have passive nanostructures, active nanostructures, systems of nanosystems, and molecular nanosystems. So passive nanostructures are just your paints and all. Passive means the nanostructure is itself not doing anything. It is just an additive. You're just adding it into something to enhance its properties, right? And for example, in 2003, I think so, in Tokyo, this mega city pyramid was proposed. So it could Tokyo is a highly overpopulated city, so they said that we will make this, and it could host 10,000 people can live in this mega city pyramid, houses and all. So everything was ready, all the maps and structures and everything. But when they calculated the structural thing, so the engineers said that this will collapse because we do not have such kind of strength in the material that was available at that time. It could not hold that much of load, so they could not make it. The steel and all that was available at that time was not able to give the structural engineers that kind of strength. But now with carbon nanotube reinforced steel, if you add carbon nanotubes to steel, it becomes like 1,000 times more stronger. So now this structure is possible. If it is made now, it will be possible. Okay? So that is one example of passive nanostructure. Then you have active nanostructures. Now active nanostructures are those that you know they do something, like they're not passively added, they're not just additives, they do something to the thing that they're applied to. For example, these gold nano shells. Now these are very important. What they can do is they can when they are injected into the human body, they can diagnose, they can discover, diagnose, and treat breast cancer. This was done in mice, but they are now trying to develop. In fact, nanomedicine is a separate field, and cancer nanotechnology, I'll come to that slide. Cancer nanotechnology is a very major field. So one would not need chemotherapy or radiotherapy. Treatment of cancer is worse than the disease. So they'll just inject, and for example, ovarian cancer, the tumors are detected when they are like big. The diagnostic imaging that we have, we can detect the tumors when like they're 1 centimeter or they're big. Okay, but with nanoparticles, uh, they can be detected when they're just started to form, like 1 millimeter or smaller than that. Okay, so that will be really very good for cancer treatment, because if you diagnose it very early, that is the problem, that it doesn't get diagnosed early. So with nano shells and nanomedicine, you the scientists are trying to diagnose it early. So if you diagnose it early, that will be really good. Why? Because then it can be treated and as soon as the it starts developing, one can diagnose it and treat it there and then. So that is this is something which is known as active nanostructure, the second generation of nano technology. Frankly speaking, basically in these four generations, on all these four generations, different groups are working on simultaneously. Some people are trying to develop more passive nanostructures, but some are trying to develop active nanostructures. We are mostly, I would say, on this generational arc, we are on the second generation mostly. All like most of the efforts are on concentrated on trying to find uh, the active nanostructures, but people are doing for third also. Fourth, still it is a dream and it is considered science fiction, but third also people have started doing people are doing work on it, but mostly the concentration is on first and second to develop active and passive nanostructures. So what is the third one? Third one would be this was in 2013. So if you scratch the for example, my mobile phone, I keep on dropping it, and there are so many scratches and everything on it. So it was a self healing phone. So scratch would heal itself. How? Because molecules, nano scale molecules will assemble at the scratching, the site of the scratch, and will self heal. This looks like science fiction, but this has already been done. They actually released it also, but this is known as assembly of nanomolecules. This is assembly of nanostructures. Okay, so assembly, that nanomaterials can assemble themselves and perform a job. That is work is going on that, and we are still at a very I would say at an infancy stage. Only conceptually we are doing things and trying to develop, but I'm pretty sure that in 10 to 15 years something major will come out, maybe less than that. And the fourth is molecular nanosystems. Has anyone read the book by Michael Crichton, Prey? It's a science fiction novel. You must be knowing about Jurassic Park and all. Michael Crichton is a very good science fiction writer, and he wrote that Jurassic Park. He wrote on which the movie was based, and Prey also he wrote, which was based on nanorobots. And the nanoparticles, they could they could assemble themselves and form any shape, like it's for example, the nanoparticles will collect themselves and they can make a laptop, they can make a human being. So this would be assembly at a very higher level. So this is actually a perfection of the third stage. Nobody has reached there, obviously. We are still working at the third stage, but this is considered to be the fourth stage. People are working on it, but still it's like a dream. So now this was a bit about nanotechnology. It's now it's I'll just like to give you an historical perspective also. So we can be very proud of this fact that the earliest nanomaterials, they are known. India has the claim to that. For example, carbon nanomaterials in Tamil Nadu, there is this place Kizadi. So in that pottery, carbon nano materials have been found. And you have to understand that the potters or the artisans at that time did not know that we are working with nanoscience. I don't think so. There is no text, but they had an empirical understanding that if we do this process or if we do this process, so we will get something like this. Now we are discovering that array isme nanotube tha. But they had an empirical understanding and their techniques were very good. So their techniques were maybe they were parallel to any modern lab working in nanotechnology today, because they could develop such good for example, this Damascus saber blades. So now they have this is now they have seen, they have tried to find out the high resolution TEM image of this, and this is composed of nano wires, cementite nanowires, right? So they did not know that we are using cementite nanowires. Damascus is so it's so long ago. So so that was an empirical understanding. Similarly, this Lycurgus cup at the British Museum, such beautiful artistry. So if you let it, its color changes. If you throw light from the outside screen, from the inside it is red. So this also is a marvel of nanotechnology. And the stained glass windows, I think the anchor did talk about stained glass windows also. So these are the examples. All these are very beautifully done and historical examples, and they have got nano technology involved in them. So it's not a new science, as I said, but I also gave you reasons, 4 reasons as to why it is so popular now. Why is so much buzz now, right? So yeah, in 1857, Michael Faraday discovered colloidal ruby gold, the gold which was red in color, ruby gold in color, ruby red in color. So this is still, these are still stable, these nanoparticles. So you can also make this in your lab, and all the theories that would like all the work in colloidal chemistry by Victor Lemaire and Robert Denninger, and colloidal chemistry, all the work now that forms the basic basis of nanochemistry. This was very important. This is dip pen nanolithography, DPN. I will also discuss this again in my lecture. So this is like you can write at the nanoscale. Okay, so that really helps you to with the nano nib you can write, nano ink and nano nib you can write. Have you heard of atomic force microscope? Atomic force microscope is something that is used in nanotechnology. So you can use the tip of that and use a nano ink to write electronic circuits at the nanoscale. That can be now used in your phones and all. And one can pattern the biomaterials and nano encryption and other applications it has. So please have a look at this video. Oh, media not found. Okay, sorry. This media file is not showing. Later on, I'll show it to you all. I just wanted to show you the amazing applications anyways. So this will also not show. No. Okay. Please have a look at this. So these are nano cars that have been devised by 6 different labs in the world. And this is a nano car racing going on. Okay. So nano car racing. These are individual molecules, 30,000 times smaller than a human hair. And they have been designed by 6 research labs. And then they sort of saw which one will win the race. Okay, so this is a nano race. This particular video says that the race is still going on, but it has finished because this video is old video. So how do you do that? So the nanoscale car, one of the car, for example, the alkynyl, it has axles that are alkynyl, made up of alkynyl molecules, and it has buckyball wheels. Okay, and if you increase the temperature, the nano car would be moving on the road for this nano car is actually a gold surface. Okay, so the buckyballs would turn, and as just as in a conventional car, and the nano car would move. So this is how 6 people designed different nano cars. Someone used buckyballs for their wheels. Someone used some other molecules, and that is how they did the race also. So that is that. And third generation of nanosystems I was talking about, that the molecules that can assemble themselves. For example, I gave you the example that I showed you, that phone that could heal itself. Okay, so these things that can, the small scale molecules that can assemble themselves, okay, that is a big thing in nano biotechnology, and people want to make robotic nanoscale assembly devices. Like you take small synthetic sequences of DNA crystals and they assemble themselves into big 3D DNA structures. So Nadrian Seaman, he did create this. And as I said, different people are working independently on different generations of nanotechnology. So this person is working on the 3rd generation. So he got a very famous prize also in nanotechnology. And yes, this also, the anchor talked about Richard Feynman. There is plenty of room at the bottom. This is very interesting. In 1959, in Caltech, Richard Feynman, a brilliant scientist, he gave a talk, and he said there is plenty of room at the bottom. Why are you doing it? Like, why etching it from the top? Why top down approach? Why not bottom up approach? Make it from atom to atom. Make a structure from atom, atom, and atom. So this was the bottom up approach. He was a very good scientist and a very good science communicator. So, he threw two challenges at the crowd. He said that I will give $1,000 each to the people, to the scientists, or to the people who could do two things. One was to reduce a page of a book by a factor of 25,000. Mane, one page of a book, okay, you take the text and you like somehow fit that text in 1 by 25,000 of that page. Okay. Second, build an electric motor in 1 by 64th inch of a cube. Matlab, take a cube, 1 by 64th inch of a cube, build an electric motor of that size. So he said he was very confident, obviously, that nobody could do this. And he was a big, he said, big promoter of miniaturization. At that time, miniaturization was sort of coming up. And he said, these are the two challenges. And he said $1,000 each for both these challenges. So in like just some months, William McLennan of Caltech made this electric motor device. He made 10 of these, and they're still there in Caltech. So he made this, and he claimed the price. But the second one took time to reduce the page of a book by a factor of 25,000. So like just 3 years before Feynman's death, Tom Newman, who was a graduate at Stanford University, he used electron beam lithography. And Charles Dickens' novel, one page, he reduced it to 1 by 25,000. So he used electron beam lithography, but now there are many techniques, very cheaper ways to write even smaller. I just told you about dip pin nanolithography, DPN, right? So now we can write using that. But Tom Newman, he claimed the second prize. He wrote with electron beam lithography. So that is that. So you know what? Yeah, this is that lecture. This is a portion of that lecture that Feynman gave, a very famous lecture. So in 1959, he gave this lecture, and 1999, uh, I'm forgetting the name of the scientist. It was Chadwin or something. He developed this DPN, dip pen nanolithography. So what you do, you take the tip of an atomic force microscope, which is very, very small, and you dip it in an ink. In this case, it was 16 mercaptohexadecanoic acid, MHA, and then you write on a surface. In this case, it was a gold surface. And he wrote, using this, he wrote on the gold surface Feynman's lecture, a portion of Feynman's lecture. This is a portion of Feynman's lecture. His dream was realized, sort of. So you can realize the spacing between these two alphabets, it is just 60 nanometers. And this, Abhi, if you see this, you cannot understand how small this is. So let me tell you that on a head of a pin, if you take a pin, on its head, such 1,000 paragraphs could be fit in. So small he wrote using dip pin nanolithography. So such paragraphs, 1,000 such paragraphs can be written on the tip, on the head of a pin. Okay, safety pin. Some people, if you will see, some people will say that Feynman was the grandfather of nanotechnology. Some would say he was the father of nanotechnology. So why is that? Because uh, nanotechnology did not gain that this term did not gain this much currency before 1986. This was when K. Eric Drexler, he wrote a book, Engines of Creation: The Coming Era of Nanotechnology. And he took this term they say that, we devised it on our own, but in 1974 a scientist had already used this term nanotechnology. Norio Taniguchi, a Japanese scientist, Tokyo University, he had already used this term nanotechnology. His nanotechnology had a hyphen in between. And this Eric Drexler, he was from MIT. He used it in his book Nanotechnology. So the term was coined by Norio Taniguchi, but the impetus to this field came after this book. In this engines of creation, do you know about ribosomes? Ribosomes, have you heard about ribosomes?
Yes. Cell organelles.
Right? So he talks about ribosomes. He took his inspiration from ribosomes, the engines of creation. You know that ribosomes are involved in that codon thing, right? So he said that if in a cell, a small entity like ribosome could perfectly perform such a complex function, then why can't we create such assembly devices? So this was a very popular book, and you should read it. So this was the sort of from this point, nanotechnology gained momentum. Now some scientists say that Feynman's lecture became popular, much more popular after this. So in retrospect, people went and then read about Feynman, that what a great thing he said in 1959. So in that sense, he's said to be grandfather of nanotechnology. Some called him father of nanotechnology, but nanotechnology came in 1959 when he said this. After that, did not gain that kind of momentum. It gained momentum after this. Then simultaneously there were so many brilliant discoveries in this field that it had to gain momentum. You see, as I told you, the reason for its major like why there is so much buzz now, that slide I told you now, that we can manipulate the atoms and molecules on the atomic scale. This is because of the microscopic tools that we have, courtesy Gerd Binning and Heinrich Rohrer. Now, Rohrer also, some people say that he's the father of nanotechnology. They discovered scanning tunneling microscope. So you can now manipulate, you can see, manipulate the things at the atomic or at the nanoscale. So that ways. Then the Nobel Prize in Chemistry was awarded to Kroto, Kerr, and Smollett for their discovery of fullerenes. I'm just showing you all just to, so that you have an idea about the major discoveries. And Sumio Ijama, he discovered carbon nanotubes. I gave you that example that that pyramidal building could not be built because the cement could not take its weight, but now it is possible by reinforcing it with carbon nanotubes. So this was Sumio Ijama who gave the concept of carbon nanotubes. I mean, who discovered carbon nanotubes. So now let me talk about some of the great inventions, some of the things that we are doing with nanotechnology. When you go and see any virtual reality program, like you go and see a 3D movie or any virtual reality game and anything, you have to wear those goggles, right? So nanotech can make contact lenses and those 3D goggles to be so small that they can be lenses inside which you can fit the display lens, okay, and that will act as a projector, and it will not affect your vision in any which way. So you don't have to put those big glasses, just a lens, and that will act as a projector. So that is something which is coming up. Then they will just inject nanoparticles, nanosensor chips, like they can fit in the nanosensor chip or inject the nanosensor chips, and it can detect if the person is about to have a heart attack, say 1 month pehle hi, it can detect 1 month, 2 months. So it will give warnings. I'll come to this later on also. And then batteries, tiny 3D printed batteries of 1 millimeter size across this, like this. So this is also an invention that is really very important, and it has absolutely revolutionized eye surgery. And the latest is that they are designing magnetically guided microbot, okay, that can be embedded in the eye. The surgeon is controlling it from the laptop, and the microbot or the nanobot can perform the precision surgery. So this is something that is they want to patent it. So uh, they have done it on rabbits. Hopefully it would be saying it will be commercialized after doing certain tests for humans also. Then uber flexible chips that can encircle a strand of hair. So now foldable devices, wearable devices. Some of you, I don't know, you all are very young people. If you use those fancy gadgets to track your number of steps taken and your heartbeat and your sleep, I don't know if you guys do that. I think you all are too young for that, but still, future of health industry is in wearables and things like this. For example, I gave you this example, a nanotech detector that can detect heart attacks. The nanos, they will just put the nano sensor chips, and have you heard of this, that there is a particular kind of smell in a person's room who is deceased, or an old person. So this smell, these are indicators, these are biomarkers, but we have no way to, our body has certain biomarkers. If someone is deceased, sorry, so if someone has got a disease, his body or her body will surely have certain biomarkers that we are not able to detect, but at the starting of the disease only those biomarkers will be there. So now nanotechnology, nano chips, we can put in the nano chips on in the body, and they can actually detect those biomarkers. They are known as nanosensors. So some in diabetes, like my work is on mostly on diabetes, so major work is being done. And if this will be, diagnostics will entirely change, because just the nano chip will be able to give you data. Same for those wearable and those like gadgets that give you data. So just a small gadget, it will give you data about everything, about like your heart, like if someone is going to have a heart attack, his diabetes status, if it is pre-diabetic or not. So all that is possible. And a major problem with batteries are like needed, and they're like something which is very very important, and they're used almost in all devices, but they are a major cause of pollution also. So biodegradable electrodes, so you can using nanotechnology, they've developed biodegradable electrodes. So those could be digested on their own. So say for example, someone has a heart issue, and he has to be implanted for that pacemaker. So they say now that the battery is there. Okay, so they're trying to make a battery that will digest itself, that the body will consume it. Okay, so that is also something on which the work is being done. Then I have already explained this. Cancer nanotechnology is a separate field. Nanomedicine is a separate field. Usme se bhi cancer nanotechnology is a separate field. So two things are there. They're trying that we get earlier detection and diagnosis of the problem. Just I gave you the example of ovarian cancer. The tumors are 1 centimeter in size. Only after that, our diagnosis techniques right now can detect them. But if you have a tumor, if you have detection technique that can, a nano biosensor attached in your body that can give you data when the tumor is 0.001 millimeter in size, then that will be great, because the problem will be detected at its infancy and it can be then taken care of. Then second is, once say someone has cancer, so targeted drug delivery is a problem in cancer treatment, because chemotherapy may they give treatment to all the cell, like to the whole body, and hair also fall, and every kind of problems arise, because that medicine is not specific, that is acting on whole of the body and cancer cells also, and we are hoping that cancer cells die. But this is not targeted drug delivery. So nanotechnology is changing that. It is giving you targeted drug delivery. The drug will go to only the, it will have markers that it will it will recognize only the cancerous cell. It will only go to that target. So that will be amazing, right? So there are so many implications for the treatment of this. And hopefully when so many labs are working on this for different kinds of cancers, for different kinds of nano particles they're trying to develop. So a lot of work is, exciting work is going on in this. And then this was Corona's time, as this told us about the importance of sanitizer. So you can actually, they've developed things that can, you can apply on your toothbrushes and all, clothes and all, and they will self sanitize it. They will have silver nanoparticles. So the bacterias, the tiny nanoparticles will kill the bacteria. So the you won't have to apply it again and again. So that ways. Yeah, as I told you, my work is in diabetes. So they're trying to make a nanotech breath analyzer for diabetes. So it will be, you will just, just get just a whiff of your breath will be able, one will be able to diagnose if someone has diabetes or not. So that will be great, because so many injections and everything for blood tests we have to do, that will eliminate all that. And one more thing I like to tell you, that nanobiotechnology is a very major field, and if some of you want to, it's a very interesting field also, and future is there. So they're working on personalized medicines, because this concept of biomarkers has entirely changed the game. Every person has a different kind of biomarker in his body that identifies, his particular thing. So they are trying to work on that, then coupling it with human genome, unraveling of the human genome. They're trying to make, uh, okay, this Nobel Prize for gene editing. What was the technique that was used for it?
CRISPR-Cas9 system.
Very good. So, using CRISPR, you can edit genes. So, nanotechnology and these kind of gene editing devices, all these has been coupled, and they want to develop. This is again a dream, but they want to develop a personalized medicine kind of a thing, diagnostic tool, just a pen, and it has all the data of all kind of genomes, and with a prick of it, it can tell you about your biomarker. So, what kind of diseases, this kind of like this person who has this kind of genetic constitution, what kind of diseases that person can have, and he's showing these kind of biomarkers. He or she is showing these kind of biomarkers. So, what kind of what is his status of his health? So this is something which is again at its infancy stage, but you have to realize that they gave the concept of aeroplanes, that we would want to fly a machine, then also people laughed at them, right? But now it is a reality. So this would be a reality, like not very soon, 10 to 15 to 20 years, but it is very exciting work is going on in this field. So nature mein nanotechnology has always been there, and best would be if we could mimic nature. Most of the scientists in nanotechnology, working in nanotechnology, they actually want to mimic nature, because nature is using it in a very big way. For example, there is this like this gecko belonging to that lizard family. It can uh, it can move like a Spider-Man. It can actually stick its feet to the wall, and then it can climb like a Spider-Man. So that is possible because of nanostructures present in its sticky fingers. Okay, so this is also like they are trying to mimic it. For example, this paper, please see, microfabricated adhesive mimicking gecko foot hair. So if we have that kind of thing, then the concept of Spider-Man would be a reality. So it'll just think about it. Now it'll have implication for army. So you will have soldiers who could actually walk on the walls. Just imagine that. I mean, it's not something to be laughed at. It can be a reality. We have papers. This kind of machine can be designed. So yeah, just a second. See, this size scale has its challenges. What are the challenges? And they're too small for direct measurements, and they're too large to be described by current rigorous first principle theoretical and computational methods. You can't directly measure them. That is one thing. And physics wise, there's some problems, because that is why these things are taking time to be for their translation into commercial products. So these are some of the challenges. And nanotoxicity is also a major challenge, because we see this is a very like recently there have been so many products based on nanotechnology. So we don't know what is the status. Is it entering into our body? Is it toxic or not? So research on nanotoxicity is also, you can see I have a data till 2015. So research on nanotoxicology is also increasing. Why? Because we don't know what is nanoparticle doing into our body. So because they can cause fine particle pollution because of their small size. And just a second, I'd like to show you something. So we did this, we investigated the phytotoxicity of nano plants in our college. We collaborated with Dr. Saloni Bahari from botany department, and we investigated the effect of copper nanoparticles on moong dal, Vigna radiata, because we wanted to know. And these were very preliminary results, and we did the tissue culture studies. But the point is, people are working in this direction. So how do you make nanotechnology safe? First thing is, you must have dependable diagnostic tools for detecting the nanoparticles present in air, water, or food. Then you must have like focused research is required on on finding out how, once the nanoparticle enters into our body, how it distributes, and how long it persists in the human body. Then methods should be standardized for finding the amount of glucose in my body. There is a standard method. But nanotechnology is a recent science. I mean, not a recent science, but it is, the products have come up recently. So there is no standardization of methods to find out the toxicity. And of course, people are so hyper about nanotechnology, the general public does not know about the harmful effects. So you have to sensitize them also and make them aware. So possible solutions are for the government to increase the budget for nano toxicity or nano risk research, okay, and strengthen the regulatory standards. India really lags behind regulation, and anyone can like claim anything, and people will apply that on their bodies, ingest that in their bodies without realizing the harmful effects. Then industry should also, strict standards they should embrace, and all stakeholders should be informed, and all stakeholders should be they should be informed, and they should be sensitized about this. And okay, time is like, okay, this I've really taken up so much of your time. I wanted to discuss this software. Students, this is an open source software, Ninithi, please note down it. And this software is available, open source software. You can draw various nanotubes, nanoparticles, all kind of nanoparticles you can draw, and you can calculate their electronic properties. So for starting, this is a very good, it is a very good pedagogical tool for faculty also. Those who are teaching nano chemistry, they can use this for the students. And please go to Nano Hub website. It has got amazing resources, amazing articles, amazing presentations, videos, and amazing, there's so much resources that you can see. So Nano Hub, you can download Ninithy software from Nano Hub or from their website also. So with this, I would like to finish. So as they say, the best things come in small packages. Small is beautiful. Thank you so much. I think now I can take questions.
Thank you so much, ma'am, for this enlightening session. It was truly wonderful to explore the intricacies of this promising technology, which is definitely going to spread its roots deeper in the near future. Now, it's time to acknowledge the queries of our participants who have been patiently and eagerly listening to the lecture. I would request Dr. Sheetal Buddhiraja ma'am to kindly take up the questions of our lovely participants.
Thank you, Anushka. Am I audible?
Yes, ma'am, you are.
Okay, thank you, Anushka. Thank you, Dr. Smriti, for such an insightful session. I hope our participants, they're really inspired by your highly sparkling words on nanotechnology. Now let's open the floor for questions from the participants. I request participants to kindly type their questions in the chat box. I can see a few questions, and let us take the questions one by one. So, Dr. Smriti, may I start?
Yes, please start.
Yeah, thank you. So the first question is by Shubham. In order to perform the respective behavior in nanoparticles, how do you customize a computer program to build a correct behavior simulator for the experiment in the research paper?
Could you please repeat this?
Yeah, sure. In order to perform the respective behavior in the nanoparticles, how do you customize a computer program to build a correct behavior simulator for the experiment in the research paper?
Okay, can I have the student who asked this question, beta, have you worked on like this field? पहले पढ़ा है कुछ? Because I will explain accordingly.
Yes, ma'am.
Sorry?
Yes,
Yes,
sure.
ma'am.
So what do you know about it? क्या किया है आपने अब तक? Because accordingly I'll explain.
मैम अभी भी मैं मतलब लर्न कर रहा हूँ मतलब कंप्यूटर लैंग्वेजेस वगैरह में, लेकिन जब मैं साइंस और फिजिक्स के मतलब वर्किंग कंडीशन को देखता हूँ तो उसपे जो सिमुलेटर बिल्ड करना होता है उसको मैम कैसे परफॉर्म किया जाता है, हम उसके एक्सपेरिमेंट कंडीशन को किस हिसाब से लेते हैं?
हो सकती हैं, एक तो सिमुलेशन अगर आप परफॉर्म कर रहे हो तो एक तो ये हो सकता है कि आप जस्ट अ सेकेंड. तो सिमुलेशन जब आप परफॉर्म कर रहे हो तो उसमें दो चीजें हो सकती हैं. एक तो आपका जो सॉफ्टवेयर है ही इसमें ऑलरेडी ये प्रोग्रामिंग करके रखी हुई है, तो वो जो है फॉर एग्जांपल आई एम अ कंप्यूटेशनल केमिस्ट. आई विल प्रेफर और फिर मैं उसको यूज कर लूँ. ठीक है, एक तो ये है. दूसरा जो प्रोग्रामर होगा, और फॉर एग्जाम्पल आई टोल्ड यू दैट दिस इज एन इंटरडिसिप्लिनरी फील्ड. इफ आई लर्न प्रोग्रामिंग तो सेकंड थिंग इज दिस कि मैं वो उसको वो करूँ, खुद डेवलप करूँ. तो उसके लिए कुछ कंडीशंस होती हैं. फॉर एग्जांपल आई डोंट नो इफ आपके कॉलेज में मॉलिक्यूलर मॉडलिंग एंड ड्रग डिजाइन पढ़ाया जा रहा है, तो जैसे मॉलिक्यूलर डायनेमिक्स की स्टडीज होती हैं, उसके पीछे कुछ सारे वो होते हैं, एल्गोरिदम्स होते हैं. तो वो सब अकॉर्डिंगली हम एल्गोरिदम लगाएंगे और उसको डेवलप करेंगे. बट फॉर दैट यू शुड बी हैविंग दैट काइंड ऑफ बैंडविड्थ, you should be having that kind of knowledge. So that means I understand that you are a undergraduate.
Okay.
So the next question.
Please.
Yeah, the next question. Do nanotechnology will help us always in the positive manner? I repeat, do nanotechnology will help us always in the positive manner? Smriti?
Yes, I was asking, can I have that person who asked this question?
Yes, ma'am.
हाँ बेटा, एक बात बताइए, आपका जो क्वेश्चन है मैंने इसका आंसर एक्चुअली दिया था एक स्लाइड में. आप क्या पूछ रहे हैं? आप पूछ रहे हैं कि ये पॉजिटिवली ही इम्पैक्ट करेगा या नहीं, है ना?
Yes, ma'am.
But Beta, I did answer this when I said that it has got challenges. And one of the major challenges that we don't know about its toxicity. Right? I did tell you about that now. So it is not that it will always impact us in a positive manner. But yes, on a scale, if you have to weigh the positives and negatives, the positives outweigh the negatives. So we have to basically be very cautious about the toxicity of nanomaterials, but it doesn't mean that we should stop discovering new things. So they are very, the positives, I would say, outweigh the negatives. That is my answer to your question. So next question, please.
Okay.
Yeah, so next question is also from Anshika. Does nanotechnology have any harmful effects on the environment?
Yeah, that is what I was saying now, that phytotoxicity of nanoparticles is an issue, and on agricultural crops and all, they do assimilate the nanomaterials. I'll send you my paper. We worked on copper nanoparticles toxicity with uh, Vigna radiata and sorghum bicolor, like maize crop and moon crop. So yes, they have harmful effects on the environment, but then you have to see, you have to, as I say, like weigh both the pros and cons.
Yeah, so this is a new topic. This is a very recent field, right? So that's why students are so inquisitive, and the kind of questions I've been reading, I mean, it's really,
That's really interesting, because
yeah,
if
that's really.
students are asking questions, that is heartening for the speaker. If they are not asking, that is the problem.
Yes, and the kind of questions, they're asking, it's really, I mean, they're really thinking, they're listening and they're thinking, no? Okay, so the next question is by Nishchit. How is IT sector helping in developing nanotechnology? Very good question. Nishchit? Are you there, Nishchit?
Yes, ma'am.
Yeah. Smriti,
Yes,
could you please?
nice name, Nishchit. Yeah. So, what is your question? Can you repeat it?
Ma'am, how is IT helping in developing the nanotechnology?
Did you hear my talk from the beginning?
Yes, I have heard that.
So, do you think that I answered this question in my talk?
Yes, ma'am. I asked it before you, ma'am, said about the topic, ma'am.
Yeah, so I'll again let's say repeat for your satisfaction that chemistry, computational hardware, IT is, if IT is not there, then to develop nano would be, a major challenge, because everything is controlled now by uh, computers. For example, I gave you the image of a scientist who developed self-assembly who made self-assembled nano DNA from the small particle. Just a second, please give me 2 minutes.
Yeah.
Yes. So we are so that scientists developed from small nanomolecules of DNA fragments, I should say. He developed self-assembled DNA, right? Now something was programmed, because सेल्फ असेंबली अपने आप नहीं होगा. सेल्फ असेंबली नाम का मतलब है कि अपने आप असेंबल हो रहा है, बट असेंबली होगी विल बी अकॉर्डिंग टू अ program. So that program, you will have to have IT for that, right? So in a very very major way, nanotechnology is related to IT. In fact, अब कोई भी ऐसा फील्ड ही नहीं है जो IT के बिना आप सोच सकते हैं. ड्रग डिजाइन 14 साल लगते थे पहले एक ड्रग को डिजाइन करने में, अब आपकी वैक्सीन 2 सालों में आ गई है. तो दैट इज बिकॉज ड्रग रिपर्पजिंग हुई, और वो किस पे हुई? वो कंप्यूटर्स पे हुई. इन सिलिको केमिस्ट्री इज कमिंग आउट इन अ मेजर मेजर वे. इन सिलिको किस पे होता है? कंप्यूटर्स पे होता है. कंप्यूटर्स कैसे, कंप्यूटर्स में सॉफ्टवेयर कौन डेवलप करता है? आईटी पीपल. सो this goes without saying. I always tell my students that paper, IT skills for chemists, and that molecular modeling paper, any paper related to computers, you should really practice it hard, because even if you're not pursuing chemistry per se, computers are a thing which is like the pen and paper of our times. So, in a major way, it is affecting in a major way. Next question.
I have a small question whenever you allow me to.
Yeah, sir, sure, you can.
Okay. My question is from Dr. Smriti. First
Hanji
of
sir.
all, thank you very much for a nice discussion. The question is, on one hand, we are talking about pollution and other things. And on other hand, we are talking about these nanotechnology, computers, and so and so. So, while developing these nanotubes and nanoparticle sector, etc., how much pollution is generated? This is my first question. And second question is, what is the ratio of benefit of nanotechnology, nanotubes, nanoparticles over the amount of pollutants and degradation in the atmosphere and other things? What is the ratio of this?
Thank you so much, sir, for your questions. Uh, that depends on how we use it. For example, I talked in my lecture about assembly. So, there is this concept that you develop localized, for example, 30% of our pollution comes from transportation of materials across the globe for constructing things. So,
No, no.
they are
My
trying to
question,
developing.
my question is
Yeah, I'm
slightly
coming to
different.
that, sir. I've understood. You were asking me about the proportion of the pollution, and that is what I'm trying to explain. That I'm giving you an example. For example, 30% of our pollution comes from manufacturing,
Of what?
transportation of transportation of materials for
Okay.
manufacturing, or otherwise in the manufacturing factories also, a lot of pollution is there. So they are trying to build devices atom by atom. They are called as single precision devices, and they're trying to, this is still at the stage. What they want is, they want to you must have heard about 3D bioprinters. So they want to have printers that can make a thing at its localized, at a particular space. One would not need any kind of different material. Only one kind of material would be necessary to make it. First thing is this. Second is, it is highly polluting. Carbon nanotubes, when they are acclimatized in our body, they can cause various problems. So, as I said in my talk, the people have to be, they have to be really sensitized about the indiscriminate use of nanoparticles. अब they are, आप please देखिए, वो वाटर प्यूरिफायर में दे आर सेइंग नैनो पार्टिकल है, क्रीम में नैनो पार्टिकल है. So people are using that, but they don't know about the harmful effects. So they have to be sensitized. But you see, if you use that nanoparticle for treating a cancer cell, then it is not harmful, right? So it has to be a balance. People are touting it as a miracle technology, but it has its disadvantages. It has like pollution is one of them, and we have no control of what it does to our body. We don't know because there is no data, because the development of the products is at such a high pace that the research in the toxicology of that is not in that pace. It has to catch up to that. So it is, you use it for medicine, you use it for energy devices, use it for solar energy, but when it comes to localized contact with your body, one should be cautious about it. So again, because I'm scared that it will cause pollution, because I'm scared that it will, I don't know what its effects would be on my body, I cannot say that I should stop using it or I should stop the research. I should be actually investing in the research related to the toxicological studies. That is
No,
what I
no.
said in my slide. There should be a lot of funding
Your, an-
to study about the toxicity.
your answer is perfectly all right. We cannot stop the research while considering its bad effects and so on, environmental effects. My question is again a simple one. In earlier lecture, I was not able to ask the question with Dr. Krishna also. When people talk about cancer, so at that stage, my questions are totally different. They are trying to remove the cancer cells without bothering or without actually predicting what is the source of cancer. I think if you first predict the source and then eliminate it, the cancer cells will automatically be eliminated, because molecules or chemicals developed, they cannot distinguish between cancer cell and normal biological cells of human body. That is why while treating a cancer patient with platinum substance, medicine, platinized medicine जो भी होती हैं, all the hair of body are gone, because
Sir, Hanji, वही मैंने, that is the example that I gave कि this is the problem with cisplatin or other chemotherapic medicines. But nanotechnology is giving us targeted drug delivery. The drug, the nano encapsulated drug will only go to the cancer cell And
How?
just
This is not possible. Do you have any
this is
example right
possible,
now?
sir. There are, sir. This is possible, and researchers have published papers regarding this. Targeted drug delivery by
Ma'am,
nano
how papers
encapsulation
are
is a major
published?
topic of research.
See,
Sir,
how
that I
papers are
explained that in my
published,
talk that
that
there
I
are
know very
biomarkers,
well.
sir, cancer cells have certain biomarkers that are different than the normal biological cell because they divide at a very rapid speed. Cancer cells, their division is not controlled, so they have got certain biomarkers. Those biomarkers can be used to diagnose
No, no, that is true. That is
Sir, can I
true.
can I can I just interrupt in between, sir?
Please,
I think
please.
it's a very good, this discussion is going on, and we have, very less time, so we can,
Okay.
yeah, talk
Thank you very
online
much.
first. Thank you, sir. And I think we'll go ahead with the questions. I think there are students still waiting for
Yeah,
the questions.
yeah. Thank you,
Thank you,
Shruti.
sir. Thank you, Smriti.
Gee, thank you.
So, yeah, another very interesting question, Smriti, from Dr. Smriti from Shubham Mitra. Yeah. Can nanotech be used to hybridize humans with artificial intelligence and manipulate our health, aging, and intelligence? I repeat, can nanotech be used to hybridize humans with artificial intelligence and manipulate our health, aging, and intelligence? Shubham, are you there, please? Are you there, Beta?
Yes, ma'am.
Yeah.
Ma'am, your voice is not clear.
Yeah, yeah. Smriti, Dr. Smriti, your voice is breaking. Smriti, we can't hear you.
Sorry, am I audible now?
Yeah, yeah, yeah. You are clearly audible.
Yeah. Yes. So, Shubham, you said that can we integrate the nano materials and into the human body, and they will have artificial intelligence. Such a great idea, Shubham. Is it your original idea, or did you
Yeah.
read about it somewhere? Shubham,
Yes, ma'am. Yes, ma'am.
it's your original idea. Then I must
No, ma'am.
credit
I'm
you.
I'm basically reading the.
You reading what?
Yes, ma'am. I reading basically many research papers on mainly customization and the other research papers on basic basis
Okay,
on
okay. So the thing is,
symbiosis.
yes, see, artificial intelligence क्या है? फॉर एग्जाम्पल जो मैंने आपको ग्लूकोज मॉनिटरिंग सिस्टम बताया कि आप डायबिटीज को आपको या हार्ट अटैक को इट कैन डिटेक्ट बिकॉज हमारे बायोमार्कर्स जो हैं उसको अब नैनो बायो सेंसर्स जो है उसको डिटेक्ट कर सकते हैं राइट सो अगर आप इंटीग्रेशन कर दे उसकी हमारी बॉडी के अंदर तो डेफिनेटली इट कैन गिव यू द डेटा एंड artificial intelligence and machine learning is nothing but data driven science so it has data it can find out certain patterns so in principle it is possible shubham but of course it will take a lot of time because right now the priority of the scientist is for detection of early diagnosis and treatment strategies for diseases like cancer or for finding out the problems solutions to the problems of energy research by using solar panels so they are using solar paints right so I don't know how much it'll be a reality one after these kind of problems are solved. So definitely in principle it is possible, and I must congratulate you for such a nice question. Either
Yeah.
you should write, you should go into the line of writing science fiction, or you should go into the line of research. So that is my advice to you.
Yeah. I think Dr.
Yes, ma'am.
Smriti, this is how, legacy of critical thinking is passed on to generations and then result in great
Absolutely amazing.
discoveries.
Yes, yes, yes.
Good, good. Question
Amazing.
was very interesting. Yeah.
Okay.
Okay, so we move to the next question by Diksha. She says, Ma'am, can you please suggest some professional journals and magazines that cover nanotechnology related issues? I repeat my
Just
question,
a
Dr.
second.
Yeah.
Okay. Just a second. Yeah. What were you saying? Journals. Okay. Diksha, beta, I suggested Nano Hub. It is a website that has got plenty of material. So you do explore that. Other than that, if you're interested in the healthcare aspect of nanotechnology, then Nano Medicine is a brilliant journal. Okay. And it is an and I'll advise you in general, because you are an undergraduate student, do read the articles, the summaries of Science and Nature. These are two major journals, not specific. Specific, like they talk about general breakthroughs in science. So one is Nature and second is Science. Then there is Discover Magazine. Discover Magazine, that is also a very nice magazine. So do this, have a habit of reading these, because brilliant ideas will come to your mind if you have a habit of reading. Okay. So one of my student, not in our even not in our college also, he came with such a brilliant idea that now he's submitting a research paper on it. So you never know. You must inculcate the habit of reading, and especially if you want to be a scientist. So these kind of journals, magazines, you must read. Yes. And next question, please.
Yeah, thank you, Dr. Smriti. Next question is from Ankita Singh. Ma'am, could you please enlist the concerns about nanotechnology and the developing world? Concerns about nanotechnology and the developing world.
Again, I'll repeat this because some part of it I've already answered. But our developing world ka sabse bada problem is regulation. If you have seen that movie Corporate, usme there is a lot of hue and cry about pesticides in the soft drink bottles. But yet everyone is in India is happily consuming those. So in our country, regulation is a problem. Even if we make rules, there are ways somehow, to circumvent those rules. And we don't take this seriously. For example, our pollution levels. Just imagine, I mean, so high pollution levels in Delhi, but still what is being done? They're not taken. So I would say in a developing economy, maybe there are other pressing concerns or what, but regulation always flies out of the window. So that, according to my personal understanding, that is the problem. But we don't have the will to. Why can't we impose? See, population is not a problem because Japan and say Hong Kong is such. For example, Hong Kong is such a good transport system, but it is highly populous. So that is not an excuse. So that attitude of not, following protocols, standardization, regulation, that is, I think, a challenge in a developing country.
Okay, ma'am. Thank you, ma'am.
Thank you. So the next question is by Sakshi. What is the negative impact of nanotechnology on the society? Sakshi, are you there? The question is, what is the negative impact of nanotechnology on the society? Dr. Smriti?
Society, Sakshi, society, why did you सोसाइटी पे क्या इम्पैक्ट होगा ये तो अभी मुश्किल है बताना, बिकॉज अभी तो डिस्कवरीज हो रही हैं. मुझे ऐसा लगता है कि अगर कैंसर डिटेक्शन के टूल्स निकल आए, हाँ, तो सोसाइटी पे तो बहुत पॉजिटिव ही इम्पैक्ट होगा. नेगेटिव इम्पैक्ट वही जो हमने बोला, पॉल्यूशन, अल्ट्रा फाइन पार्टिकल्स होते हैं, तो वी डोंट नो हाउ दे आर कमिंग इनटू आवर बॉडी एंड what they are doing into our systems, how they are persisting in our systems. So are they being excreted or not? So society as a whole फिर बनती तो human beings से ही है ना, तो as a whole it is possible that it can lead to certain diseases that we've not heard of. So that can be the effect on society.
Yes, ma'am. Thank you, ma'am.
Okay.
Welcome.
So the last question is from Dipanshu. How nanotechnology is used in artificial intelligence? I think we have already taken up this question. How
Yeah,
nanotechnology is used in artificial intelligence? If you would like to add anything to it, Dr. Smriti. Dipanshu, are you there?
Dipanshu, what do you understand by artificial intelligence?
Ma'am, sorry to interrupt, ma'am. He's my classmate. He had to leave because there was some emergency on his end.
Acha, chalo, no
Really sorry.
problem. So okay, no problem, Sita. So I've already answered this integration of nano biosensors into our body that will collect data, and that can be used by AI and ML tools, artificial intelligence and machine learning tools, in a big major way, and that will eventually we'll come to that, but I don't know in our lifetime or not, but certainly in your lifetimes. So that was that, yeah. And I also have to say that I am at Miranda House only, and if any student has any question or has any idea, research idea or anything, they can directly contact me on my email, and I really love to work with students. So that I wanted to add. So thank you so much for all of you for your patience and brilliant questions, and to the organizing committee.
Thank you, Dr. Smriti, for patiently listening to the queries of our participants and answering them. I think our participants, they have been benefited by the information shared by you and then the queries you have taken up for them. Thank you so much, Dr. Smriti. Now, over to you, Anushka.
Thank you, ma'am.
Yeah.
Thank you, Dr. Smriti, ma'am, for addressing the inquisitive queries of all the participants. As we proceed to wrap up today's webinar, I would like to invite Dr. Shiza Zaidi, ma'am, faculty member, Department of Chemistry, Ramjas College, to deliver the vote of thanks.
Okay, am I audible?
Yes, ma'am.
Okay. Good afternoon, everyone. It gives me an immense pleasure to deliver the vote of thanks for today's webinar. On behalf of the organizing committee of this national webinar, I extend a warm welcome to all of you. It is my pleasure to thank Dr. Smriti Sharma Bhatia, our invited speaker of the day, who delivered such an enlightening and enriching talk on nanotechnology. It covered everything from the history of nanotechnology to cutting-edge research and pedagogical tools related to this technology. I also thank you for taking out time from your busy schedule to grace this event. I take this great opportunity to thank our respected principal, sir, Professor Manoj Kumar Khanna, for providing immense support and for encouraging us to achieve many such endeavors. I would also like to extend my gratitude to our vice principal and IQSC coordinator, Professor Hemant Kumar Rajor, for his unconditional support and motivation behind this event. My heartfelt thanks goes to our Taj, Dr. Suruchi, for her valuable suggestions and encouragement. Finally, I extend my gratitude to all worthy colleagues and participants for their encouraging presence. I cannot thank you enough for making this event so successful with your active participation and interaction. I want to thank the student coordinators, Anushka Man, Sahil Chakar, and Soumya Srirangam, who really put in best of their efforts to make this event successful. We continue this trend of enhancing knowledge and come up with something more promising in future as well. I once again thank everyone whose contribution has made this webinar successful. Now, I would like to conclude this webinar by this inspiring quote from Anatole France: to accomplish great things, we must not only act, but also dream, not only plan, but also believe. With this, I take your leave. Stay safe, stay healthy, Stay safe, stay motivated. Thank you very much. Over to you, Anushka.
Thank you, ma'am, for your kind words. It was indeed a very fruitful and a very informative session. I would now request all the participants to kindly fill the feedback form, the link for which is being floated in the chat box. It is essential that you fill it up in order to receive the e-certificates. I request everyone to kindly turn on their cameras for a group photograph. Thank you, everyone. So with this note, we hereby come to the end of today's meet. Thank you, everyone, for being such patient listeners. I hope you take with you plenty of knowledge from today's session. It was an honor to be present here with all of you. I would like to thank my mentors, our teacher in charge, respected Vice Principal Sir, Principal Sir, and also my fellow student coordinators, Sahil Jakhad, Anshika Dwivedi, and Soumya for helping me in conducting this event successfully. Thank you, everyone, and have a good day.